Hello guys, welcome back to my channel Maison African Motives. Still working on O-level mathematics. In this platform, we have got the question that we are going to focus on, which is on construction. So actually, we asked this question, guys. Most of you said you want to work construction with bearing. So that's what we are having, guys. Here we've got construction, which has got bearing. We just want to see how do we attempt such typical questions. Actually, you must know the basics of construction. I think we did the construction of angles and everything in our previous classes. So yeah, it's going to help us to attempt this one. So here we've got a question which is answer the whole of this question on a sheet of plain paper. Use ruler and compasses only. Take note, you ruler and compasses only. All construction arcs and lines must be clearly shown. Okay, so that is the part that you're given. So we are given that there are three schools, P, Q, and R, are such that the bearing of Q from P is 45 degrees and that of R from Q is 300 degrees. The distance P and R is 18 kilometers and Q is due east of R. Okay, so this is bearing, guys. What you need is a sketch, definitely. That's what we're gonna need here. So I'm just going to put this aside. Let's hope our sketch is going to be fine here. Okay, so let us just have our sketch and see what it's going to look like. We have got the first part here, that is the first part, the bearing here, the bearing of Q from P. Remember, guys, the bearing is always taken where it is given from. So it's from P, which is 45 degrees. So let's just say this is our P here. So we've got our North Pole at P. Okay, so this is our point P that we have. And 45 degrees, remember, this is three-figure bearing, where I told you that this bearing is taken from the north in a clockwise direction. So we're going to take north in a clockwise direction. That is 45 degrees is somewhere here in between these two. That is where we are going to have our 45 degrees from. Okay, so that is where our P is, and our Q is somewhere in this line. That is where what we need, that is what we know. We just know that Q is in this line, along this line. So we are going to have our Q at the end here. We are now given this point, and that R is actually 300 from P. That is R from P is 300 degrees. Okay, so from P, which means we are referring to the same point, which is this P. There is a 300 degrees, and 300 degrees, we know that that one is in the third quadrant. Remember, this is 90, 180, 270, 360. So 300 is somewhere in this quadrant like this. That's where we are going to have our angle of 300 degrees. So I'm just going to mark from the North Pole in a clockwise direction like this. So this angle here is 300 degrees. So where we are going to have our Q, our R in this case along this line, because this is of what? This is of R. So R is the one that is going to lie in this line. So we do not know exactly where that R is, but we just know that it's along this line. But here we're given the distance between P and R is 18 kilometers. That is from P to R here, we are given distance 18, and on this scale we are given that using a scale of 1 centimeter to represent 2 kilometers. So we're going to divide this 18 divide by 2, which is going to give us 9 centimeters. So here we've got 9 centimeters. All right, so that means we are going to have our P here, our R here. There will be a North Pole at point R. So this is our R here. We are going to have our North Pole at this point like this. Okay, now at this point R, we are now given that Q, which is the one that we said we do not know exactly where it is located, but it is due east of what? Let us see here, our Q. Okay, is due east of R. So this Q is due east of what? East of R. So what does it mean? It means from this point R here to the east, because remember, your North Pole is like this. This is north, this is east. So to the east, it means from R here to the east, straight in this line to the east like this. That is where we are going to have our point Q. So what does it mean actually? It means our point Q is going to be located at the point of intersection of this line, which is 45 degrees, and this one, which is in the what? In the, which is to the east. Okay, so I'm trying to mark up this to this side. Let's just hope it is going to allow us, or this page is actually done. So let me mark our Q. So let's just say our Q is somewhere here. Okay, That's where our Q is. So just know that the Q is going to be the point of intersection of these two lines, this one and this one. But how are we going to have this diagram now at the end? This is your sketch, guys, from the bearing. The bearing, that is what it only gives you. Now we want to construct this because the question is using a scale of 1 centimeter and 2 kilometers. Construct a single diagram. So it must be on a single diagram to show the relative positions of the three schools, P, Q, and R, and that is 5 marks for that. Okay, so just want to see what you're going to have at the end. So let me just try and adjust this side. This is our sketch here. All right, so okay, we can even reduce it a little bit so that it can be clear at the end. Okay, so this is what I'm going to do. I'm going to show you how do you actually construct these with your bearing part. Okay, so as you can see, you've got a North Pole. So where do we get our North Pole from our construction? This is bearing, but from construction, how do you get your North Pole? That definitely, like I said, guys, everything has to be from the ruler and what? And these two, the compass. Okay, so this is what you're going to do. We can just put this aside for a little bit like this. Okay, so always construction, I told you guys, it must start from a line. So everything has to start from a line. So we're going to start from a line like this. So something of this nature. So from this line, that is where I need to have this angle here of 90 degrees, because this is a North Pole. So for you to draw a North Pole, this one, you just simply have your 90 degrees. Remember, North Pole, guys, will be having 90, 90, 90, 90. So for you to draw that one, it means you simply need to construct 90 degrees. So that's why I said you need to know the basics of construction. So how do you construct 90 degrees, guys? We talked about this. And we're not going to waste much time. Remember, for you to have your 90 degrees, you're just going to mark an arc along the line where you want to start your construction. So here I want to start my construction at this point. So from this point that we have, we just mark 2 points from this, mark a point here and another one on this part. Okay, so these are the 2 arcs that we need. And we know that from these 2, we are going to open more than half of the line. We mark an arc on top of the line like this. On top here, we just mark an arc. We're supposed, yes, to have another arc down, but since we've got our reference point, there's no need for us to do that. We just need this arc and the other one from this side. So actually, there's no need for you to have arc down and other one. There's no need. If you've got this reference point, what I'm trying to say is that if this reference point is there, this one, there's no need for you to have those 2 arcs. Yes, you can do those 2 arcs, it's fine. There's no problem for that. You can still obtain the same thing, but in this case, there's actually no need, because as you can see, we've got these 2 points. So as long as these 2 points can join each other, then it means our line is fine. So there was no need actually for us to have the other point. So this is our North Pole here that you're going to use, and must be continuous. The North Pole, North Poles are always continuous. Okay, so that's what you're going to have. So this is the North Pole that we are having at P, and that's our point P. So I don't know, we can just put it here to say this is our P. Okay. So take note, P is your reference point. What am I trying to say if I say P is your reference point? That is where the other angles are going to be created from. The angle of 45 degrees, remember, from P to Q, there is 45 degrees. So I have to construct this 45 degrees, all right? So I have to construct the 45 degrees from what? From P. So remember, the whole of this angle was 90 degrees. So it means 45, I have to bisect this angle. That is what it means, okay? So I simply need to bisect. Remember how you bisect your angle, guys? You step at this point, which is the point of intersection where you want to bisect the angle. Just open more than half of, just open a distance of your choice so that you can mark an arc on this line. You mark also an arc on the other side here. All right, so remember what I said, guys, without changing this distance, you have to mark from these 2 points, mark an arc inside the region where you want to bisect. So it's somewhere here. Then we do the same from this point to this line back. As you can see, they are going to intersect, so I can join like this. So that will be my 45 degrees in this case. So this is what you're going to have. So let us take this part and join. All right, so I'm just going to join direct to the point P, which is at that point at the intersection of these 2 points. By doing this, we have constructed an angle of 45 degrees. Okay, so we can even just try and adjust a little bit so that we can extend this line. I don't know if it is going to be accurately along that same line, but somewhere, something like that. Okay, so this is your 45 degrees here that we have created. So we've created an angle of 45 degrees. But as you can see, we do not know so far the exact position where this Q is going to be located. Remember your Q here, this is the point Q, and we are not given, even the distance is not there. So how are we going to know this Q? We just leave it like that for the meantime. Because remember, we are told that it must meet with this line from R. So at least we can work from R because there's something that we're given. We're given that from P to R here, it's 9 centimeters. And also the angle that we are given here is 300 degrees. But how do we construct 300 degrees? Okay, this is what I want you to see from this information. I want us to see how I'm going to have our 300 degrees. Remember, this is a north pole like this. And this angle like this is the one that is 300 here. But here there's a remaining angle that is in between here. As you can see, there's a remaining angle here. So from 360, minus 300 degrees, we are going to remain with 60 degrees. So which means we can just construct 60 degrees inside this region. By constructing 60 degrees, we are constructing 300 degrees. Even if you cross-check on our last video, I talked about the construction of 60 degrees, that it produces also 300 degrees. Okay, so that is the case. So that's how you construct your 300 degrees. So you're going to just construct 60 degrees on this side here. All right, so let us put our compass here. So remember how you construct 60, guys. All you need is to have an arc, which is like a semicircular arc. So you can just mark your arc from this part. This is our semi-circular arc like this. Then from this arc, what are you going to do? We are going to mark from this point, which means the arc back to this line like this. So you can just mark your point like this. Okay, so by doing this, guys, you can see that we have created 60 degrees on this side. So that means the remaining angle is actually 300 degrees. So that is the case. Okay, so as you can see, guys, that is the only case that you are working with. So you just need to join these two here. All right, so I'm just going to increase a little bit so that you'll be able to join this part. So I need something like 60 from this side. Oh, that will be somewhere here. I just need to mark this point and join, guys. So I don't know. Yeah, something like this, something like this, something like this. All right, something like this. Just join a little bit from that point, and you can even extend here a little bit. Okay, so this is 60 degrees inside this one. Don't indicate because you do not need this 60 degrees. It's just a part that is helping you. So this is 60 degrees. So what does it mean? It means the rest of this angle is going to be 300 degrees. So from this same north pole in a clockwise direction going this way to this point, this angle here will be 300 degrees. So that's how you simply construct your 300 degrees. So at least if I know that this is 300 degrees and I know that from this P that I'm indicating here, let me just erase this P and put it aside. So this is our P, just put it aside here. We know that from this P here to the point which is R along this line, we are supposed to have 9 centimeters as per our diagram here. We are having what? 9 centimeters. So this is a sketch, guys. It's not something that is accurate. This is the accurate diagram, okay? So this was just a sketch. So don't worry about how the angles look like. So this is 60 degrees, and we need 9 centimeters for us to get to the point which is called R. So we have to measure 9 centimeters. So what you're going to do is that you have to place on your ruler, you measure 9 centimeters from your ruler here, okay? But in this case, I'm just going to use this direct because it gives me dimensions. If I open like this, it can tell me that now I am at 9 centimeters. But you're supposed to use your ruler there to measure these 9 centimeters that you see here. All right, so like I said, we have to step. We are going to step at this point with our 9 centimeters. So this will be your 9 centimeters from your ruler. As from your ruler, this will be your 9 centimeters, guys, okay? So you have to mark a point like this. So you're indicating to say, okay, this is where I am having my 9 centimeters at this point here. So this is where my R is located at this point. So this is where our R is located. All right, so at least I now know where my R is located. That is at this point here. Okay, so the question is, how are we going now to have the North Pole? Because we are told that at R here, we're supposed to have the North Pole. As you can see, at R, there's a North Pole. Okay, so how do you construct a North Pole? This is the idea that you're going to use. This line, which is our North Pole here, and this North Pole, they are parallel lines. So it means for us to have a North Pole, this angle, if it is 60 degrees, it means also this angle here must be 60 degrees. Remember the Z concept, the Z angle concept that you have on parallel lines. So that is the same thing for you to have a straight North Pole, a direct North Pole. These two angles must be the same. So this is what you're going to do. We are just going to construct, since this angle here is 60 degrees that we have got here, since it is 60 degrees, I'm just going to write, but we are not going to indicate this one. It means we must create an angle of 60 degrees from this direction here. Let me just put a sketch like this. We must have a 60 degrees here. This is where you're supposed to construct our 60 degrees. Once you construct 60, it means this is now a North Pole. But how are we going to construct? So that is the question. All right. So let us see how are you going to construct these 60 degrees. All we need, remember your 60 degrees, all you need is to mark a point from this point here. Okay, this is where we are having our point. We mark a point where we are going to use as our semicircle. So you can even start from this point here, or we can even reduce a little bit like this. Okay, we can start from here, our semicircle. Then from this, we said we have to mark from this point, the point of intersection on the line, and your arc back to that point that you have, back to this arc here. So as you can see, they are going to join. So I can even start joining from this, like this one. Okay, so I've joined these two. So it means if I join from this point R here, this one will be at 90. It will be actually a North Pole. That is what it actually means. So we are going to have a North Pole. Since these two will be parallel, there's no way that these two angles, they are equal. There is no way that you can create a Z angle and these two lines, they're not parallel. There's no way like that. So it means this is going to be same. So we are going to have our North Pole here. So this is just a North Pole by joining this. So we are now having a North Pole at R here. And this part is actually not that necessary. They are too big. Okay, these arcs, they are too big. Okay, anyways, that is what you're going to have in this case. So this one I was just indicating so that it helps us to understand what is happening. So I'm saying if this angle is 60 and this angle is 60, definitely these two lines, they are parallel to each other. These two lines, they are definitely parallel to each other, and it makes these two lines to be North Poles. So how am I going to construct now? Because I have a North Pole like this, I'm left with the line to the east. So to go from the west to the east here, what does it mean? It means we are supposed to have 90, 90, 90. So you're supposed to construct an angle of 90 degrees from this line here. So you're supposed to construct 90 degrees from this line. So how do you construct 90? Remember, guys, your 90 degrees, just like what we did from the first part, we have to open from this point here. We just have to mark two arcs that we are going to relate with on this line. So these are the two. This is what I'm going to mark. I'm going to mark from this point an arc here and another arc on this side like this. So I've got these two arcs here. With these two arcs, then I have to open more than half. Okay, so I have to step back to this arc here. They need to point on this arc. Make sure that the need to point is on the arc. Then you open more than half of the line. This is actually more than half. As you can see, it's more than half. Then we mark our point. We are just going to mark an arc on this side. Okay, so that's an arc here. We do the same on this side, of which there's no need for us to do this, guys. We just have to know that it's going to pass through this point, so there's no need for you to do that actually. Okay, so do the same from this point here where there's a blue here, or there's a blue here. We mark back our arc. As you can see, they are going to join here. We mark back on this side. They are going to join here. Okay, so that's it. We have got constructed 90 degrees by joining. We are going to have 90 degrees, and that means we have got our 90 degrees from this point. Okay, so let's join. Now let's join these 2 points. Just going to increase this side. Okay, so if you join these two parts here, we are going to have a 90 degrees, and make sure that is a continuous line and it's actually bigger. Okay, like this. So this is what you're going to have by joining these 2 points. Okay, So if you are to join, guys, we are going to see we have completed our diagram now. Everything is now there. So this was just for assistance of us to draw this part. So this is what you're going to have at the end with the measurements that you had before. So actually, because it's construction, this is not actually direct. You just have to put maybe something of this nature, just erase a little bit of the diagram just to make it clean. Do not remove these arcs here that you're having. No, these arcs, they are part of your working. So this is what your diagram was going to look like. And all these arcs, they'll be marked. So it means where this point from R here, as you can see, from R to this line, we are going to have our Q. So it means from R here and from Q, these two lines, they met at this point. So when they met, that is your Q. So this is where our Q is located. So finally, we have got our Q in this case. Okay, there's something that I just want to verify again if it doesn't change. So this has changed according to measurement, guys. You see now it's at something like 11 comma. Is because I have adjusted this diagram of mine. So it means actually the measurements that you're going to have at the end are not exactly the ones that you, but this is your sketch. Like if you're doing it on your book, doesn't change because you can't zoom in your book. Okay, your book is just like that, but here because I'm zooming in and out, so these measurements they won't be direct. Like if I try to measure again, they won't give me the exact thing, but that is what we had here. It was our 9 centimeters. Here still remains as our 9 centimeters here. So this was your 9 centimeters from this one. This one, okay. So that's what you're going to have in this case. So let us see the other question that we are being given. In this part, we are now given item 2. We are given use the diagram to find the actual distance between P and Q. So this is just distance. So take note is the actual distance. So you measure the distance between P and Q first. Okay, so this is your P here, and this is your Q on this diagram here. This is your P, and this is your Q. All right, so your Q is directly at the point of intersection here. That's where your Q is here. So you measure this distance. Okay, so that is what you're going to do. You have to measure that distance. After measuring the distance, you use this scale. Remember, we said 1 centimeter represents 2 meters, 2 kilometers. So whatever that you're going to get, you multiply by 2. So measure that one. Like I said, guys, I can't measure here because I've adjusted this one. So it's not going to give us the exact value, but that's what you're going to do. You measure, then you multiply by 2. So that was the case. Okay, so that was it, guys. Then the item 3, we are now given to construct the perpendicular. Take note, the perpendicular from R to PQ produced. When they say QP produced here, let me see this one. QP produced, it means the line QP, you can extend it, but how do you construct a perpendicular from a point to a line? Okay, so remember I talked about this, how to construct a perpendicular from a point to a line. Okay, so that is it from R to QP. Okay, so this is our R here. So we want to construct 90 degrees from this R here to this line QP, but they said produced, which means we have to extend this line. Okay, so we are going to extend the line QP like this. Let us just put in our ruler here. So I'm just going to extend that line. That is what they say when they say line what PQ produced. Okay, so that's what you're going to have. So let us just extend our line a little bit here so that we can have, maybe it was going to work like that, but it's best for you to just extend since you do not know what is going to happen later on. So that's it, guys. We do not know exactly what is going to happen. So let us just extend our line. Okay, so I just extended this line a little bit from where it was. Okay, so just a smaller extension like this. So now from this extension, we want to construct 90 degrees from this point R here. I don't know what ended up happening here, but this was actually 90 degrees and so forth. I hope we still remember what was there. So we need to construct from this point R here. Remember, this is your R here. So we are going to construct what? We are going to construct 90 degrees. So how do you construct 90 from R? This is what you're going to do from this R here. Okay, let's just remove this part here. Okay, so I need to take this Okay, so this is what I'm going to do from the point R. I'm going to mark a point, okay, from this R here that I'm having. This is our R here where it is located here. So what you do, you just open this to a height, to a certain length that enables you to have 2 arcs on this line, okay? So it must enable you to have 2 arcs on this line. You must have 2 arcs on this line, which are going to be created along this line that you're having. All right, so maybe if I can just reduce it a little bit, it can actually work properly. Okay, so this is what I'm trying to say. From this point R here, open a distance which allows you to mark an arc which crosses this line at 2 points, all right, at 2 points. So it actually means this one is not enough. As you can see, it's not crossing at 2 points. Okay, let's try to reduce a little bit. Before this, let's try to reduce a little bit and see, okay, this one is not going to cross. So we need to extend again this line. If it doesn't meet at 2 points, you have to extend that line. That is what it means. You have to extend your line. Okay, so let us extend again. So that is why they say to line PQ produced or QP produced, it must be extended line. Okay, so if we extend at least this way, it can work this time. All right, let's get back to our and see. Yeah, this time we can manage to have it. So as you can see, this arc that I'm drawing, I want you to see what is happening. If I draw an arc like this, you just mark from any point, but as long it is from the line PQ. So from line PQ like this, I'm going to mark an arc. This is my arc here. Okay, so this arc that I'm drawing. So what I'm saying is that this arc must pass through 2 points on the line PQ, this one. So it's not a matter of being in within P and Q. It can even extend from this side and this side. As long it is on along that line, is fine. So with this, what am I going to do? I'm going to mark back, okay, from these 2 points that I have indicated so far. So I'm going to mark back. In fact, I wasn't supposed to change this distance, guys. So I need to get back here and redo this part. I'm not supposed to change this distance here. The needle point, it was here. Okay, so this was it. Okay, as you can see, it didn't change. All right, so this is what you're going to do with this distance. You mark back from these 2 points. Make sure that your needle point is at these 2 points. So you can start with this point. Okay, if you mark back, you're going to see it crosses through that point. Your reference point is repeating from the reference point. So here it's not going to have an effect. So on this side, all right, on this side, we are just going to do this so that it can be fine. I'm just going to shift a little bit so that we'll be able to work it nicer. Okay, let me adjust. Okay, let me just adjust my paper alongside. Okay, guys, you see now. Okay, all right, all right, all right. So this is what I need here. All right, guys, everything seems like it's taken off now. Okay, I have it here. I want to just shift this a little bit, yeah, up. So exactly up like this. All right, so with this up, I'm going back here. I'm going back to those points. These are the points that I had. I have to maintain that distance again, guys, so that it becomes the same. Okay, so as you can see, it's the same. So we said we are going back to these 2 points. You mark an arc back here and another one at R here. So you just have to mark an arc somewhere here. It can work. Okay, that's something like this. Okay, then we have to move from this point at Q here. All right, so at Q, I'm just going to shift maybe something like this. So guys, that's the difficult part here, and not at Q here where it meets the blue one, this one, the blue and this one. Okay, so if you are to see, you are now at that point, so you can mark back here. As you can see, they are going to join. If you mark here, and if you mark back, it must pass through that R. As you can see, it's still passing through the R here. So that means we are in the right direction. If you join that one, it's going to pass through R. Okay, so you join these two, the point of intersection here at this point of intersection and at R here, that is where you are going to join. So by joining these two, it means we have constructed an angle of 90 degrees from that point. Okay, so that's how you simply construct the 90 degrees from this point. Okay, so that's what you're going to have from this point here and this point. So all you need is to make sure that you join your points properly. Okay, so just a little bit, I think we can win if we just move a little bit here. All right, something like this. Okay, so that is it, guys. We can join from R here to this point of intersection. So by joining this, we are going to see that the line that is being drawn, when it meets this line PQ, this PQ here, it is going to meet this line at what? At 90 degrees. So that's how you construct this one. So this one is going to be made at 90 degrees like this. So that's our 90 degrees. So that's what it was the question saying when it is asking us to construct the perpendicular, that is the perpendicular in this case. All right, let's take this back here. I hope it's clear here on this point. That is the perpendicular. Here, construct the perpendicular from what? From R to QP produced, like that one. Okay, then if you have this perpendicular, the last part now of the question is to calculate the area of the triangular field. PQR, giving your answer in square kilometers. Okay, so what is the area? So the area of the triangle, all you need is to work from that triangle that you are given. You have to play around this triangle here and see what is going to be the best formula to use. Okay, remember your triangle PQR, this was PQR here, this was the triangle, and we measured this we measured this side from P to Q. Remember, you measured this length here from this P to this Q. We measured this, and R, P is there. So that measurement that you had, and we say this angle here in between is 60 degrees. Remember, when you constructed, you say this is 300, and the remaining angle here is 60 degrees. So definitely I'm going to use area of a non-right angle triangle to say that area is equivalent to half of AB sine theta or sine C, which is half of A and B. These are the sides, which is RP. So you measure RP, you convert it to kilometers. You measure PQ, this one PQ, you convert your answer to kilometers again. Then you multiply by sine of the angle, which is 60 plus 45, which is 105. So I want you to measure these sides, these two sides, you multiply them. So here, like I said, guys, if I'm to measure this part, is not going to give us the exact thing because of what I have adjusted this part, unless if we are to do this, let me see if it is going to give us the 9. Okay, somewhere here is actually 9. Okay, so it means here it was going to give us something like 6,4. Yeah, something like 6,4. So PQ is something like 6,4 centimeters. Then you multiply by 2 of the scale. Okay, remember your scale was 1 centimeter representing 2 kilometers. So you have to multiply that answer by 2. So 6,4 times 2 is going to give us something like 12,8. So this will be 12,8 kilometers. Okay. And your PR is the one that you were given before. That's your PR. Remember, it was 9 centimeters, which we took from what? From that 18 kilometers. Okay, so this is going to be your area. So it's going to be half of 12,8. So RP here, which is 18. So it's half of 18 times 12,8 times sine 105. So it's going to be sine 105 degrees. Okay, so that will be your area. So if you have to simplify this, that's half of 18 by 12,8 by sine 105 degrees. I'm obtaining something like, make sure that your calculator is in degrees. Sorry, my calculator was in radians. Let me convert to degrees. So you're going to obtain something like 111,27, something like that. So it depends with the units. I mean, with the dimensions that are on your diagram there, but that is what you actually needed in this case. So guys, this is what you're going to have for construction. So construction actually, it's not like you are going to have something that is exact. You are going to work with the sketch. Okay, the sketch is the most important part that you work with. From that sketch that you are given, you can formulate the triangle or whatever shape that you are given, because the sketch tells everything. Like you can see here, our sketch actually can tell everything. So you work from this sketch that you have, and with that sketch, you can actually have the actual diagram using the information or the idea that you have on what, on construction, working with angles. That one is very, very important for you to understand. But I think everything, guys, is actually there on this question. So that's what you had, guys, from Meso African motives, working on O-level mathematics till we meet again.